We're going to take a look at finding the distance between a point and a line. So this is going to work very similar to finding the distance between two parallel lines, and we're going to start just by graphing the line and plotting the point. All right, so our line here is in slope-intercept form, so go ahead and start with your y-intercept, and then use your slope. And get a few good dots on there because we're going to be using them because we need to get that perpendicular line at some point. All right, so there's our line, and now we want the point -4, 2. Okay, so now what we need is a perpendicular line that goes through that point and is perpendicular to that original line there. So we're going to kind of sketch that on here just to give us sort of a basis to go on here. So we're sketching that. So we already know one point that this line goes through, and that is our original point, -4, 2. So the distance we're finding in this situation is this distance right here. So we need 2 points. We need our first point, and then we need this intersection point down here, which is going to be our second point. So in order to do that, we need the equation of this perpendicular line. So we're going to do this in point-slope form because that's what we know. We know a point and a slope. So the point that we know is the point that it goes through, that -4, 2. And the slope is going to be the opposite reciprocal of the slope of the red line. So the slope is going to have to be -3/2. So that's going to be y minus 2 equals -3/2 x plus 4. Now, just like finding the distance between two parallel lines, we're going to need to solve a system of equations between these two lines to find that second intersection point. So I want this to be in slope-intercept form to make that a little bit easier on myself. So I'm just going to quickly convert this to slope-intercept form. We don't want plus there, we actually want -6. Okay, and then we'll go ahead and add 2 to both sides. Okay, so now that we have the equation of our perpendicular line in slope-intercept form, we can go ahead and solve our system. So the system we're going to be solving is this equation that we just found. I actually don't want to rewrite it. And then our original line, so y equals 2/3 x minus 5. So we need to solve this system to get our intersection point. So in order to do that, we'll just use substitution, so essentially setting those right-hand sides equal to each other. So -3/2 x minus 4 equals 2/3 x minus 5. So we'll go ahead and subtract 2/3 x from both sides. We'll get -13/6 x minus 4 equals -5. Adding 4 to both sides. And then finally multiplying by the reciprocal -6/13, we'll get x equals 6/13. And again, just leave it as a fraction. That way we're not rounding prematurely. We can just work with that fraction. So we have part of our second point, and we're going to need to get the second part of our point. So in order to get the second part, we're just going to substitute that x value in. Doesn't matter which equation we substitute it into. Y equals -3/2 times 6/13 minus 4. And we're going to get -61/13. Okay, so it's fine. Again, just a nasty fraction, but don't worry about it. We have calculators. All right, now we have 2 points that we're going to use, right? We have our original point, and then we have the intersection of the line perpendicular through that point to the other line. Now we just want to apply our distance formula very carefully, making sure that we're entering it into the calculator very carefully. So we're going to get that our distance equals the square root of -4 minus 6/13 squared plus 2, and then plus, because it's minus and negative, 61/13 squared. Now that we're at the end of our problem, we can go ahead and round, and we're going to round this to the nearest hundredths. So our distance is approximately 8.04.